Assalamu alaikum participants and especially Dr. Akmes. Now we are going to start our second session of global webinar series with Dr. Akmes. Let me introduce you with our today's guest speaker from United Kingdom. Dr. Akmes is very highly professional and results-driven senior project manager with over 9 years experience managing multi-site and disciplinary projects spanning from waste to nuclear waste treatment delivering projects to meet strict performance timelines and cost targets. Effective networker, experienced in community building with extensive collaboration with academia and industry. Expertise in managing technology development and innovation through effective IP management, commercial investment, and market adaptability of novel technologies and concepts. Managing a wide team and provide rapid solutions to pressing issues. So without any further delay, I would like to invite our guest speaker, Dr. Ekmes, for today's session on wastewater treatment. So up to you, Dr. Ekmes.
Assalamu alaikum, everyone. So first thing is, Jazakallah khair for inviting me to present today. So it's a pleasure for myself to just give a brief intro about myself and then about wastewater treatment. So just a brief overview of my career. So my career has not been what you would call a straight line trajectory. So what I've done over the years is I've studied, studied while working, and then progressed through my career. So it's just a snapshot of how my career so far has originated and why I'm right now. So I started as a chemist. So back in the year 2000, I studied chemistry, but I didn't want to just study chemistry. So at the very beginning of the millennium, there was always the idea that science and business and management were going to be a symbiosis coming together. So at the very early stage of my career, I wanted to embed onto that path. So I studied chemistry, business management. When I finished that, I started lecturing chemistry. So while lecturing chemistry, I did my master's degree. So this is one of the things which I've done is I've always tried to keep myself updated and increase my knowledge. And within 2 years of being a chemistry lecturer, I was the head of the chemistry department. And I left the job then to go and do my PhD in chemical engineering at the University of Manchester. So during my PhD years, I met a lot of people, met a lot of world experts, experts in the field, for instance, in arsenic removal, treatment of water, looking at remedial solutions, and also looking at new concepts, ways of taking technology from cradle to grave approach. And I met a lot of friends, made good friends. You don't need many friends in life, but you need a good circle of friends who have each other's backs, people who would always help you to achieve better in life. And finishing my PhD, I embedded a new path, which is something which in the UK is driving a lot of innovation, which is called a knowledge transfer partnership. So what I've done is I work with the University of Manchester and a technology provider, which is an industry, and we built a new system for treating water. So following that path, I fully embedded and work into industry where I progressed my career as a process engineer to a project manager, senior project manager, and effectively being the head of project department. And now I'm currently the head of business development in a company, which is Colina, which I'm going to present further, which looks at treating water and wastewater using electrocoagulation. And at the same time, with last year pandemic being in, I started an executive MBA. So inshallah, I should be finishing that next month. So I've tried to keep myself busy. On top of all of that, I have 3 kids. So that keeps me very busy. But alhamdulillah, it's all about managing our time. So that was a small brief intro about myself. Now, I'll take you through what I'm currently working at and the company I'm working in. But one of the other things which I would like to point out is I am, alhamdulillah, well connected with experts in the field of water treatment, wastewater treatment, cross technology across the world. So I've worked across the world, China, India, South Korea, America, in UK, and of course, and in Europe. So I am well connected with people and it's effectively trying to build solution to problems that exist. Now, A bit about Colina and where we are based. So Colina is a UK-based wastewater and water treatment company, and it has a unique technology central around electrocoagulation, and we provide a containerized system. So we work both in the industrial and municipal sectors, and for industrial application, Colina uses its proprietary electrocoagulation technology and complements it with solid separation technologies. I have a small video which will give you guys a better idea of what is included and not in Colina's offering, for instance. And what does Colina do? So we operate both in the industrial and municipal sector worldwide, and we offer effectively a chemical-free alternative to water and wastewater treatment. When a project comes into the company, what we do is we look at the project from a cradle to grave approach. So we have a team that looks at the project design, we plan the project, look at the project path with all the different milestones, and then progress through installation, commissioning, and of course, handover of the project to the client. So one of the things which is very, very important to us and Colina is the support that we give to the clients and also sustainability. So there is a big drive currently in the UK. The UK goes through what we call an asset management program. So this program lasts for 5 years, and then every 5 years you have new asset management programs. The current AMP cycle is looking at phosphorus removal and also looking at driving innovation towards chemical-free treatment and carbon neutrality. So the current asset management program in the UK is valued at £52 billion. Out of this £52 billion, £5 billion is just for phosphorus removal. So phosphorus is a big issue worldwide because being a natural resource is being depleted. The problem we have with phosphorus, it is so embedded within industries that you have to find an alternative way to either recover it and capture it and bring it back into circulation. It's circular economy type approach. And this is what we are doing at Colina. So this is just a snapshot of different installation of Colina across the world. So we work in the oil and gas industry, the food and beverage, wastewater, chemical wastewater treatment. That's just where the space we operate. So I mentioned about electrocoagulation. I'm not sure whether you guys are familiar with electrocoagulation. So electrocoagulation is not a new technology. It is not new, but the way Colina has innovated some aspect of it, that is new and that is patented. So by basic definition, electrocoagulation uses sacrificial electrodes. So the setup that you see on the side, it makes use of two terminal electrodes. The terminal electrodes are purely current feeders. And in the middle, you have stacks of sacrificial electrodes. Normally, these sacrificial electrodes can be mild steel or aluminum. And what happens when you apply current through, you effectively dissolve these electrodes and you produce what we call coagulate ions. So how is that comparable to some other existing technologies? So electrocoagulation can be compared to chemical dosing system. So for instance, Fenton's reaction, where you would use ferric chloride or ferric sulfate. Effectively, what you're looking at is you're using the active reagent, which is iron. So the iron, what it will do normally in water and wastewater treatment, it will coagulate pollutants from the liquid phase and flock it out and bring it in a solid phase. The challenge you have with chemicals is you don't have pure chemicals. There's always a number of different counter ions which are present. Electrocoagulation, the main advantage is whatever you place, you're gonna. Sorry, there's a noise there. Yeah. So whatever your plate is, you're going to dissolve it and produce your pure ions. And these ions then are used to take out contaminants from your wastewater. So this is a typical containerized system that Colina offers. This container is can be from anything from 10 to 40 foot. And you would see at each end of the container, there are inlets and outlets connection, which allows effectively for a plug and play system. So what we do, we take a container, we drop it on the site. All we need from a client is connections for the electricity and connecting the influent and a line for the treated water. That's all we require. And that solution is ideal for many places which suffer from footprint or suffers from having existing facilities on site. So I've got a small video. So if you just watch that, just a minute or so. So what I've shown you in the video is a complete containerized treatment system. So what that allows you is within a single container, you have multiple stages of treatment. So on any sites I've worked across the world, there is no two wastewater sites that has the same quality of effluent. In cleaners, a containerized system, we take into account for these kind of issues. So the solid separating technologies that we have up front of our electrocoagulation system enables us to get control on the quality of effluent we want to treat. So screens takes out bigger particle of solids, and the electrocoagulation system allows us to dose the required amount of coagulants that we generate. This is modulated by just applying an amount of current. Once we dose the coagulant, it needs a retention time. So the dissolved air flotation system allows for this. It allows the wastewater with the dose coagulants to get the right retention time to be able to coagulate and effectively flock out the pollutants that can be recovered or is recovered as a sludge. Now, this is very important because this sludge in the utilities sector that we're working in the UK, most of these are phosphorus or phosphate that has been coagulated and removed as a sludge. This sludge which is formed is then suitable to be reused as fertilizers in agriculture. So that in itself creates a circular economy and allows for phosphorus being a very important natural resource to be reused. So that's one way where we promote sustainability.
Are you, Doctor?
So some of the main advantages of Colina is electrocoagulation itself. I can't hear you well. There's a.
Now we can see the slide.
Hello?
Please go ahead.
Can you see the slide?
Yeah, now we can see.
Can you see the slide? Yeah?
Yes, thank you.
Okay. So what we're saying is electrocoagulation is not new. So what is new about Colina is the plates. You see one of my colleagues holding two plates in his hand. This is the size of our sacrificial plate. It is effectively 20 centimeter by 20 centimeter. Traditional electrocoagulation system would use a sacrificial plate, which is a meter by a meter, which is massive. You can imagine it's not only massive, it's very heavy. So what that means is if you need to change a plate, there is downtime on your treatment. You also need a frame to be able to lift the plates. In the case of purpose-built, so you don't necessarily need to build a treatment system. All you need is a container. It goes to site, allows you to benefit from all the different technologies which is present in there. So where is Colina operating? So we have a lot of application in the UK. So in the water and wastewater treatment sector, in the utility sector in Scotland. We work a lot in the food and beverage industry, where we offer two types of services there. So it's cleaning the effluent to allow company to meet discharge consent, but also in the UK, when you discharge water, you need to pay the wastewater treatment system, operators a certain fee. This fee is based on a Mogdon formula. So what DOC and DOC removal. So main applications for is decentralized treatment, remote application in small municipals, which we do in Scotland, removal of nutrients, phosphorus, ammonia, metal ions removal, CO2, TOC and DOC removal. So this slide just gives a brief benefit on how Colina's technology enables money saving. The technology itself is a greener application, resource efficiency, and containerized solution. So all in all, what it is we need technologies that can treat new problems that we've seen. So I've been on a lot of different sites across the world. The main issue that you see is, in many cases, you see reticent to changes simply because existing technology that has been put into place at that time, 20, 30 years ago, was fit for purpose. But now it's not, it's still doing a job, but is not as efficient. So with new advancement in analytical tools, what we are also seeing is we are seeing contaminants that we didn't know existed before. And also the effect that these have on the ecosystem. So there is effectively needs for new technologies to address these new problems. So what Colina is doing is we are providing not only technology, but we're providing a solution to the issue of water pollution. So essentially, we're trying to, what we do is we say we try to extend that lifetime of water. It gives water a second chance, essentially. So the main challenge facing the world is effectively the water challenge, because the amount of clean water that is available for use is very small. So this is some of the benefits of Colina's system. In general, this flow table shows different components that are present in our containerized system. There is something which is very important to us, is we have remote telemetry. So the remote telemetry, what it allows me to do, for instance, I can have a plant on the site. I don't necessarily need to send one of my engineers to go and look at the numbers. I just dial in from my laptop and I can set parameters and I can have the readings. So this is what we usually do for any clients. We design the whole system, we provide all the required documentations, and also we give them that support, the know-how. And that's just a few data. So one of the containerized system can treat up to 400 cubic meter per day. That's a 40-foot container. However, I'm looking right now at scaling the same 40-foot container to double the throughput. So I'm looking at a new design that allows to get to nearly 1,000 cube a day using only a 40-foot container. That's for industrial application. For municipal application, what I'm doing is looking, which currently we have one in Scotland, is just our electrocoagulation cell within a container. We can easily do 80 cubic meter an hour. So this is mostly industrial application data. So we remove a lot of fat, oil, and grease, heavy metals, COD, phosphate, sulfates, nitrates, so suspended solids. So a lot of different parameters. So it's a technology that can do a lot, but doesn't necessarily do everything. So this is one point which I'd like to stress on is there is no technology on its own that can be able to do everything. What we need to look is we need to look at having complementary system, get the best out of every single technology and build a treatment train. And this is one of the things that I do is I look and assess different technologies and treatment chain and see how best to retrofit technologies, but also how to get the best out of existing technologies. So a typical engagement at Tolina is this is typical, the inquiry, and we look at whether a project is feasible and we establish a framework. Framework is very important because we need to make sure that client objectives are well defined, and then we start with an engagement. And effectively, what we do on site is commissioning, installation, and training of our client engineers. So this is just a snapshot of some of the companies that we're working with right now. So it takes a lot of oil and gas, food and beverage. There are some of the utilities I haven't had a chance to put on there. So yeah, so we are quite busy and working on different fields. And if you have any question, just please feel free to get in touch. You got my contact details here, so don't hesitate to reach out. I'm more than happy to help. And if there are any of you guys need any support, I'm more than happy to provide that as well. Thank you. Thank you, guys.
Thank you, Dr. Akmes. Now,
hello, Akmes.
Yes.
I am Sohail. Are you listening to me? Hello.
Yeah. Yes. Go ahead. Who is this? Please introduce yourself. Hello.
Yes.
Hello.
Can you hear me now? Yeah.
Yeah. You hear loud and clear. Please go ahead.
Hello, Akmes.
Yes.
Hello.
Yes, I can hear you, but I don't know whether you're hearing me.
Okay. Yes, I am listening to you. My question is that what is the mechanism for routine maintenance and flow? How will be flow inlet and outlet will be managed for maintenance activities of your technology?
So in terms of flow, all the containerized system has already embedded pumps that deals with the flow in and flow out. The main maintenance requirement is plate changing. That is tailored to applications. So depending on the applications, in industrial application, we've seen that maybe we might need to change the plates every 2 days. In industrial application, it's a matter of changing the plates every 2 weeks, if not every month. And this operation itself takes only a minute or two.
Okay, if we change plates after every two weeks, 2 or 3 weeks,
yeah,
then in that scenario we have to divert flow, inlet flow to other side, or how we will manage it?
No, not necessarily, because the system is a multi-cell system. What it is while you're changing the plate on one cell, the system is still in operation, and the whole process only takes a minute to do. So in the containerized system, it's not only one cell which is in operation, there are up to 4 cells. So you would not change all 4 cells in one go. You change, say for instance, in cell 1, you open the cell, put the new plates in, back up and running within a minute. Cell 2, 3, and 4 already running because they can handle the duty.
Okay, nice. And my second question regarding total flow from some industrial activity.
Mhm.
If flow increases from the required capacity of your, as you was showing in your slides,
Mhm.
we have to put two containers, or how will it will execute?
So depending, say for instance, one of the things that we can do is we need to assess what is your total flow on the site. Then we can build to spec. What I mean by building to spec is, say for instance, a container can do 480 cube per day and your treatment site is 600 cube per day. Then there is scope to design using larger cell to capture that flow. But if the flow is too big, say for instance, it's 1,000 cube, then what I would suggest is one of the options. Either it's two containers or build within GRP sheds the required number of cells within that.
Okay. Have you any project initiated in Pakistan
Not,
regarding
not
this
yet.
technology? Not yet. Okay. Okay. Fine. Thank you.
You're welcome.
Thank you.
Any other question from any participant?
Hi, Ahmed. It's Adil here. How are you?
All right, bro.
How are you?
Alhamdulillah, Adil, alhamdulillah.
Just a quick question. I'm sorry I missed the start of the presentation, but just wondering where exactly this fits in terms of a wastewater treatment plant. Would it be a replacement for a secondary sort of a biological treatment process, or would it come after that in terms of, would it be a tertiary treatment step?
So it would not be a primary treatment system. It most likely sits as a secondary system, and we could possibly replace your biological treatment system. However, it's mostly cited as a secondary treatment, Adil.
Okay, and is it effective in removing BOD?
Yes, BOD, COD, metals. We do a lot of work. So currently, we have a plant on site at Scotland, Scottish Water. So with Scottish Water, we're looking mostly at nutrients removal for phosphorus, but part of the work is also the residual BOD present in there. Just looking at your COD BOD ratio and look at biodegradability of the water.
Okay, and the waste from this, is it a sludge product similar to what you get in biological treatment?
Yes.
Treatment, yeah.
Well, you would form less sludge. The reason is because when we are dosing using our electrocoagulation system, we are dosing pure coagulants effectively. So you see 40% less sludge produced. And the sludge that is also produced, for instance, we are looking at phosphorus removal. It has the phosphorus trapped in it, and we just use that back into agriculture as fertilizers.
Okay, so last question is, what's the, in terms of adaptability to varying loads? So if you say you've got differing loads coming in of BOD or COD, how flexible is it to
Okay,
that?
so one of the things is we would like to see historical data to give us an idea in terms of the sizing for the plants. Based on the historical data, we give us an idea what's the fluctuation we see on the site, both in terms of flows and concentration. Using this data, then we are able to tell the clients how big a plant you would need. So that would cater for your variability on sites.
Okay, thank you.
Ekmas, people are asking for your presentation.
I'll send a PDF of that later on, inshallah, through email, and then you can share it with them, no problem.
Okay, thank you. Any other question? I think there is no more question for today's session.
Okay, thank you very much. If there are no more questions,
you're welcome.
We must thank Dr. Ekmas for his very enlightened presentation. And I hope the participants have gained a lot of knowledge from this. And we look forward working with Dr. Ekmas in future as well. And we will also request his some contribution in a magazine that we can do through email. So thank you very much, Dr.
Jazakallah khair.
once again. Can you hear me, Dr. Sir?
Thank you so much for having me today.
Yeah, thank you very much. This was a great
Okay.
pleasure.
Okay, Jazakallah khair, everyone.
Jazakallah, thanks a lot.
Session upload होगा हमारे YouTube channel पे.
Okay, assalamualaikum.
Yeah, this will be uploading we have a standalone channel on YouTube, PCMA channel. So we will upload this lecture on this channel, and the participants and others can benefit from this. So it will be a PDF as you allowed already.
Question or answer.
So there's a belated question, like Dr. Akmas. Can you handle this, please?
Can you specify the limitation of this technology?
Can you specify the limitation
So
of this tech?
yeah, so one of the things we need to bear in mind is that because we use sacrificial plates and we need some energy, is we need some conductivity in the wastewater. So we will not be able to, for example, to treat a water that has very, very low conductivity. We can treat it, but we would need some sort of salt dosing. So conductivity is a requirement.
Dr. Agnes,
Yes?
I think financial angle is missing in your presentation. What it will be cost if we go to install a 40 feet one container?
So it's not missing, but what it is it is on a case by case basis, because I need to understand first what is the requirement. Based on that, then I can have a look at the financial engagement.
Okay, thank you.
No problem. So if you need anything else, you've got my details. Please feel free to reach out, inshallah.
Inshallah.
Okay. Okay, then. Allah Hafiz. Okay. Assalamu alaikum.
Allah Hafiz. Wa alaikum salam.